Hello, good evening, everybody. Today, like I said on Twitter, I'll be trying to showcase how I do some of my analysis. But I do realize that most of the people here would not be knowing much about R. So those people, for them, I'll be making some separate videos to give a gentle introduction into R. Today, I'm going to basically show how I collate the data. Collate meaning that I've already downloaded some of the data, and that data is lying as CSV files in some folder in my computer. Then I'm going to collate them into one data frame, and on that data frame, we'll try to do some analysis. Specifically meaning analysis by suppose the green Friday candle analysis that I had done a while back. I'll just repeat the entire analysis in front of you. This is going to be a slightly long video, and to cut short some of the boring portions when I try to make the functions that I've already made, I'm going to cut and paste the functions, but I'm going to explain what all I have done in this video. Within those functions, what happens and how I made those functions, that all I'll be explaining. So let's just start it off. I'll be sharing my screen now. Okay. So first important thing is that you have to understand I do not work on RStudio. I prefer to use the console itself, the R console here, as you can see. And I prefer to do all of my coding on Notepad++. Okay, so there are certain functions on Notepad++ that I really like, and I've just gotten used to it. RStudio will probably provide you much better functionality. If you like it, you can please go ahead and use it. So today, all I'll be using is going to be base R. I'm not going to be using any packages like dplyr or any of the tidyverse packages. Everything is going to happen on base R, and I'll show you some easy intuitive methods of doing the backtests. Okay, so the first thing is where my files are located. So my files are located, suppose I want to use the CM data files, that is the cash market files. Okay, so in the cash market files, I've collated all the cash market files in my D drive under the folder stocks. Inside that NSE-CM data, inside that Bhav copy downloads. Inside that, I've got year-wise listing of all of them. And here, at last, I've got one specific one, which is after 2017. You have to understand that when we try to collate large volumes of data, basically, if I try to collate 1995 to 2022, the data is going to be so huge that it's probably going to eat up a lot of your RAM, and it takes some time to collate. Okay, so to save some time, today I'll be doing the analysis only on the post 2017 data. Let me show you the data here. It is in the exact format that the NSE publishes. It is like CM01 April 2019 bhav.csv. Like that, we have got multiple, all of the files of 2017 onwards. Okay. Now, before we get on to the collating of the files, let's just see the structure of the files inside. Just open up one of them. When you open up one of them, you'll see how all of the data is organized. So the first column is symbol, then the series of it, open, high, low, close, the last value, previous close, total traded quantity, total traded value, the timestamp, that is the date of that day, the total number of trades, and the ISIN number of that script. So what we are interested in is Nifty. Suppose today we are only going to do Nifty. So I'll just see if there is a Nifty in here. So I'll control F, Nifty. It produces the Axis Nifty first. Let's go down, ICICI Nifty, this, Nifty Bs, Nifty Es, Axis. Okay, so we do not have the index data in this. All we have is the Nifty Bs. So we'll be using the Nifty Bs. Okay, so for now, first what I'll do is, so normally what I do is, I'll collate the data, and while collating the data itself, I'll select out only the portions of the data that I want. But for showing you today, I'll be collating everything en masse. It will take some time. I'll collating everything en masse, and then I'll break down the data into the, like, selecting out the Nifty Bs, etc., etc. I'll show you everything. Okay. So I'm closing this file now. Now, important thing is that when you are going to get some files out of some folder in your computer, you need to specify the path that the R will take to download those files. So for that, you need to press shift. You need to keep pressing shift and right click on that folder. Okay, so here then you will see that there is the option called copy as path. Now, if I without pressing shift, if I right click, you'll see that there is no option like that. That option only comes if I keep pressing shift, click on this and right click, copy as path. So I'll copy it as path. Now it has been copied in a character format, as a string format. Okay. So now let's just start it. So first I'll write my first line of code, that is data, suppose, or data.files, data.names, suppose, is equal to list.files path equal to, I'll paste the path. Now you can see that the path has been pasted here. One important thing you need to understand about R is that in that the path has to be specified as the opposite slash. Like here it is the forward slash. It needs a backward slash for it to work. So I have specified the backward slashes. 1 minute, I'll just change it to R. It will look better basically. Now data names is the object name that I'm giving to a list of file names that it will be collating. Okay, so this list.files basically only creates a vector. Vector is basically a series of anything. Okay, so series of the same anything. Like if it is a number, then it will be a series of numbers 1, 2, 3, 4, 5, 6, 7, 8. If it is a character, then it will be a series of characters like A, B, C, D, or Abba, Amma, this, that, like that. It will be a series of characters. So here I'm creating a series of characters of the file names. Okay. So for that, the function is called list.files. Okay. Then I specify the path as I've specified here. Next, I'm going to specify whether it is going to be recursive or not. Recursive means that if there are any subdirectories inside the directory that you are specifying, then it needs to collate from those also. Okay, so recursive equal to true. Okay, and then I don't only want the file names. I want the entire character string, that is d/stock/nsccm data /bhav copy download /post 2017 /cm01 apr 2018 bhav.csv. I want it in that complete format. For that, I need to specify full dot names equal to true. Okay, so now I'll be copying this and pasting this on the R console. Okay. So you can see that the command has been run. Now let me just show you what this data.names contains. Whenever you want to see a portion of it, like the top portion of it or bottom portion of a vector or a data frame, you use head. Head is for the top portion. So head of data.names, data.names is this. So you can see that it has given the first six data names, that is D stocks, NSCM data, this, that, 01CM 2019 bhav.csv, and like that, so on and so forth. Okay, so this data.names now contains a vector of character strings which encompass the entire path to the files that we want to download. Okay, so this is just collation of the file paths. Okay. Now what I'm going to do, I can do this thing using just a single line, but I'll make it a little simpler and I'll make it into a loop. Okay, so for I in 1:2 length data.names. Okay, so this I'm starting a for loop. In a for loop, this I'm using it as the iterator variable. That is, this number will keep changing from 1 till the length of data.names. Whatever number of characters are there in data.names, it will encompass until the end. Okay, so I've started the for loop. After this, I'll read the CSV file within that character string. Okay, within that file path. Okay, so I'll suppose name that as temp. Okay, temp is your temporary file that I'm creating. Temp is equal to read.csv data.names I. So here I have specified that I want the ith number of data.names. So when I is 1, it will read the first data.name. When it becomes 2, it will read the second data.name, so on and so forth until the length of data.names finishes. Okay. Now there are some other arguments which are there in read.csv. That is your header. Header means that it will specify the first row as the names of the columns. Header equal to true. And there is another specific thing which is useful is strings as factors equal to true. So I'm basically specifying that if there is any string inside that, it can be it has to be a factor, or I can even make it false. Basically, then it will read it as a character. Either way is fine. You can convert it during your the future analysis also. We can make it false also, no problem. The default right now is false. In the earlier versions of R, the default used to be true. Okay. So here I am reading it. After that though, now that I've read it and there is an object called temp which contains that CSV file. Now where do I put that CSV file for collation into a large data frame? Right, that is the main question, right? So I have to specify before I start the loop that I want to have an empty object within which I'll be filling up these files. Okay, so that suppose I'll call final data or this data, and I'll be making it as a list null. That basically means that it's an empty list. Okay, list is a object in R in which you can put anything. Basically, normally a vector has to have the same thing within it. In a list, you can put anything in sequence. Like you can have a data frame, JPEG object, like that's basically a picture, an image. Then you can have the next part of the list as a vector. You can have the next part of the list as a character string, whatever you want. Okay, you can fill up into a list. Now lists are, because they are flexible, that is why I tend to use them more. So here I'll be filling the list with CSV files one after the other. Okay, so temp here. After that, now that it has been read, I am going to fill it into the data. Okay, now data I. Now this is the way, this double square bracket is the way you specify a list object. Okay, you index a list using double square brackets. So data I is equal to temp. So the first object inside the list is going to be temp. Okay, and I've specified it as I. So basically, after in the next iteration of the loop, we'll specify that the second object of data has to be the new temp. So the temp will keep on being overwritten, and that object is going to be filled into the ith space inside that list. And I am closing the loop. Now after this, I'll run the loop. Okay. Now, but one more thing is there, that when you are doing long operations, like it takes some time for it to finish, you want to see that the progress is happening, right? Because sometimes you might have a problem in the code and nothing really happens, right? So for that, what I'll do is I'll specify that print a character string. For making a character string, there is a specific function called paste 0. Data dot names I, that is the first data dot name, then done. Okay, so it will print this at the end of each loop, and after that, one more important thing you have to do is flush.console. So in this, the console gets refreshed every time the loop runs, so the print happens. Otherwise, the print happens in the background and you can only see it if you click on the console. So I'm flushing the console. Now let's see how this works out. I'm pasting it on the R console. Now you can clean up the console by just pressing Ctrl L. Now I've cleaned up the console. Now I'm going to run this. Okay, enter. Now you can see one by one, all of these are getting filled up into the list. It will take some time to be finished, so we'll just wait. Okay, until this finishes, I'll just teach you some more things. Now, once this data gets collated into, once all of the CSV files get collated into this data list, okay, then what I'm going to do is I'm going to make them all into one data frame. Okay, like right now they're separate data frames. I'm going to combine them into one data frame. So for that, there is a general function. Let me just make this as, suppose, collated data is equal to, there is a specific function called do.call that you can use to apply on list objects. Do.call rbind comma data. Okay, so this is the base R version of collating everything in rbind basically. Okay, but there is one, so this one is a little on the slower side. So because of that, I prefer a faster, more efficient function which is there in the data.table package. So I'll be calling on that to do this collation. This is data.table double colon. So basically, whenever I do like this, like data.table double colon the function, it will automatically load the data.table package and use that function. Otherwise, the other method is that you can by yourself specify library data.table. By that, the data.table package will be imported into the R space, and then you can use the function within that. So here I'm calling it in one line basically. The function is called rbind list, and I'm going to specify data. Now, one important thing is that sometimes the CSV files can have one extra column accidentally. Okay, so when that sort of thing happens, like it will happen once in 100 files or 200 files, something like that. But whenever that happens, if you try to collate everything into one data frame, the R will give you an error. So to circumvent that, there is a convenience function in rbind list in which you can just fill up any extra columns with NAs so that it doesn't cause any problems in the collation. So I'll specify this fill equal to true. So with this, the entire data frame will be created, and it will be created into an object called call data. Okay, so here we can see that the entire thing is done. Okay, now let's just see what is the length of data. That will tell us how many data frames are in that. You can see there are 1113 data frames. Now I'll be collating everything into this call data using this script, this function. Now I'm pressing Ctrl L to clear everything, and I'm entering this one. So you can see that call data has been created. Now let's just see how many dates are there in call data. Length specifies the length basically of a vector. Unique basically helps us to select out unique elements from a long vector. Like if it is 1, 1, 1, 2, 2, 2, 3, 3, 3, unique of that vector will give you 1, 2, and 3. Okay, so I am going to use this unique on to see how many dates are there, unique dates are there in the call data. So unique call data dollar timestamp. You can see that it is 1113. So basically it is the same as the number of objects in the data list that we had created. So now we have got one entire big data frame of all the cash market files from 2018 till now. Okay, so after this we'll be selecting out the nifty bees. Before that we have to clean up the data a little bit. Clean up basically meaning that we have to see what class each of the columns are, and we have to see if those class meet our criteria or not for the further analysis, or we have to modify that. So for that, there is a specific function called sapply. So sapply is used to apply a function across columns of a data frame. But important is that the output of that function has to be a single element. Okay, so just look at what I'm doing. Sapply on call data class. So class will tell us what type of variable it is. So here you can see that it has given all the classes. So here you can see symbol is a character variable, series is a character variable, open is a numeric variable, high is a numeric variable, low is a numeric, close is numeric, last is numeric. All of these are numeric. However, what I'm interested in is the timestamp, because the timestamp is basically the date, right? So, but that is being recognized as a character. I need to change it to date for further analysis. So that is something that I'll be doing. Okay. So for doing that, what I'll be doing is I'll be specifying the date, call data. So before that, we need to know what type of date it is. So this is a little complicated part. So bear with me. Okay. So first I need to see what type of date it is. So head unique call data dollar timestamp. So I am calling out this one. So in this, you can see the way it is structured is first there is the date, which is in a numeric format. Then there is a hyphen. Then there is the month, which is in alphabets. Then another hyphen, and then there's the full year 2019. Okay. So now I need to specify to R that this is the format of the date which is given. I want R to convert it into whatever format of date it uses usually. Okay, so for that the function is called as.date. So just see how I'm doing it. So call data dollar timestamp. So I'm telling it that this I'm trying to change this variable is equal to as.date call data dollar timestamp, comma. Now I have to specify the format in which it is there in that. Okay, so the way to specify that format is start with a quotation, %d. This specifies the day, basically the day of the day month year. Okay, then there is a hyphen. Then the month is in form of the alphabets. So for that, the notation in as.date is small b. Okay, if it is the complete month, then it is capital B. If it is a abbreviated version of the month, then it is small b. Another hyphen, then another percentage and capital Y. Capital Y is the complete year notation. So then close. Now this will change it into this format. Let's see. So I'll run this. It will take some time to run, because it is going through all those columns, right? Okay, so now it is done. Now I'll show you how it has changed. Okay, so head call data. I'm going to see the top of the call data. In this, you can see the timestamp has been changed. So earlier the timestamp was in this format, the 01 April 2019. Now it has become 2019 0401. This is the native state in which R recognizes date. So it has converted all the dates into this format. Okay. Now sometimes the date in the Bhav copies can be wrongly specified. Then R can produce some very weird values. Okay. So for that, we need to at least check the min and the max of the date. Okay. So that we are assured of the quality. Okay. So min call data dollar timestamp. Okay, so it starts at 2018 beginning. So we are clear on that. What is the max date which has come? It is still 1st of August 2022. So I'm happy with this. Okay, so I'm going to use this perfectly now. Now after this, the next important thing is I need to select out Nifty Bs from the cold data. Okay, so for that, I'll make a separate object, okay, which contains only Nifty Bs data from the call data. Okay, so let's just call that object NF. Okay, so how I'll be pulling out that is the interesting part. This thing is called indexation. Okay, so how I'll be calling it out is call data. So to read this, I'll just write it out, then I'll read it out to you. Okay, so how this works is that I'm specifying that within call data. Okay, call data is a data frame. So data frame will have two components, rows and columns, right? So whenever you want to specify something of rows, let me just show you. So call data R comma C. Okay, so this is the format in which you have to pull out. Okay, so suppose you want the first row of call data with all the columns. Okay, then you will be writing call data first row, all columns means empty. Okay, so this will give you only the first row. Suppose you want the first column of call data, then you will be specifying it as empty row comma 1. So this will give you the first column. Okay, so here what I've done is I've specified that I want only those rows. You can see that I've put the comma here, and whatever I've written is before the comma. So I'm specifying the condition for rows. Okay, so in the condition of rows, I am specifying that call data dollar symbol has to be Nifty Bees. Otherwise, I don't want that row. If it has Nifty Bees, I want that row. Okay. So in R, whenever you are using double equal to means it will lead to a logical vector basically. Okay. So if that first row does not contain Nifty Bees, the result of call data dollar symbol double equal to Nifty Bees will be false. It's a logical. Okay. If it contains Nifty Bees, it will be true. Okay, so basically I'm specifying that I only want those rows in call data in which the condition call data dollar symbol equal to Nifty Bees is true. Okay, now let's run this. I'll just delete all of these. Now I'll just run and get the data for NF. Now let's just see how many rows NF has. N row NF. It has got 1130. Obviously, every day there will be one row with Nifty Bees. So it will be equal to the number of timestamps. Okay. So with this, let me just show you how the data looks now. NF. So you can see that symbol are all Nifty Bees, and you have got the open, low, high, close, everything. And you can see that there is the timestamp. Okay, so now one important thing is you can see that the timestamp is not in order, right? Order meaning that we start at 2018 beginning, but here the first one is 2019 April. Okay, so we want to order the NF. So for that, the function that we'll be using is this. It will be similar to this one. Okay, so just note the difference and the similarity. NF is equal to within NF. Okay, I want order NF dollar timestamp comma close square bracket. So basically I'm specifying the condition in which I want the rows of NF. Okay, so let's just run this. So head NF. Okay, so now you can see that it is starting at 2018 1 and going down in the series of date, like in the order of date. Okay, so now that we have specified this, next thing that we want to do, suppose I want to find out day-to-day returns, like today to today close to next day open. Okay, suppose I want that. Okay, now this thing can be done in a very easy vectorized format. Okay, but I'll break it down into a few steps so that you understand it much better. Okay, now we already have a column of close and we have a column of open. Okay, so what we want to do is we want to see the difference between today close and next day open. That is the gap, right? So this gap we want. So right now the data is today close, today open. I'll be creating a column in which the next day open, basically the next day open is adjacent in the same row as close, the same day close. Okay, so just see now, NF dollar next open is equal to, so if we are doing next open, that basically means that we have to pull it up, basically meaning that the first element of the open has to be removed and the last element has to be padded with a NA. Okay, so NF dollar open, sorry, C NF dollar open -1. So NF dollar open is a vector. Okay. From on that vector, I am removing the first element, that is -1, and I am concatenating a NA, missing value, at the end, because the next day open we do not know yet, right? So this is the next day open. Now let's see the head of NF. Now you can see that this next day's open here 1080 has come up to this row. Okay, so now we'll be able to subtract this next open from previous close to create next gap. Okay, so let's do that. So I'm doing this specific thing. So in this, one important thing I forgot to tell you, this C is a function to concatenate. Whenever you want to concatenate one vector with another vector, you use C. Okay, so here I am concatenating a vector of NF open with the first element gone with a NA. Okay, so this is what I've done. Now I'll be creating the gap vector, that is NF dollar gap is equal to NF dollar next open minus NF dollar close. Okay, so next day open minus today's close gives you the gap. So this movement that I did of creating a new column, okay, I did mainly because vectorized operations in R happen very quickly. Okay, so I could have written loop to just subtract this from the next day. That becomes a very painful process. It's a very long process in an entire data frame. Okay, so it has to check this day minus, create it on this this element and so on and so forth for every row. So when you are doing it vectorized, it happens simultaneously. Okay, so it happens. It's much more efficient if you do it in a vectorized format. So here I have created the NF dollar gap. So let's see it now. So you can see the gap has come. Okay, so this is basically the point difference between next open and previous and the previous day's close. Okay, so this is still in points. Okay, you can change it into percentage if you divide it by last day's close and multiply it by 100. That depends on how you want the gap. You want it as a percentage change, point change, log change, however you want to make it, you can make it within this operation. Okay, now that I have made the gap, I want to check the returns. So whenever we want to do a back test, right, I'll explain to you a simple way of doing a back test in any data frame. Okay, so first thing that you do, you decide how many days later returns you want. Okay, suppose you want 1 day return, 2 day, 5 day, 7 day, 20 days, 1 month return, 60 days, 1 quarter return, 120 days, 6 month return, whatever number of days return you want, you first decide. Okay, then I made a specific function for getting those columns of returns adjacent to the same row in a vectorized fashion. Okay, now I'll be showing you that function. Okay, so let me just see, not in this one. Okay, not in this one. Let me just check and get back to you. So this is the function. Let me just go back to this new page. This is a pointless thing. Okay, so this is the function that I'm talking about. Okay, so how I've structured the function is I've made the function for a variable X that I'll be entering and days for which I want the return to be. Okay, so how it works is future price is Cx minus C1 is to days. Those past few values will be removed off, just like we did in the next open thing. Okay, so we'll be removing off some of the days, padding it with NAs. Okay, and point change is future price minus X and return the point change. Okay, so I'll be so this function, if you are like if you want to copy, you can pause the video, type it out in your computer and try it out. Okay, so I'll be doing it using this function. So suppose I want 1 day return on NF. Okay, NF dollar D1 ret. Suppose that is the name that I'm giving to day one return. That is an object which is the ret func NF dollar close. I want close after 1 day close basically, and 1. That is the number of days I want. Okay, so I'll be running this function. After running specifying this function, clean it. Okay, so now look at the NF. You can see that there is a specific column called D1 ret here. Okay, in which the 1 day that is close to close, today's close to next day's close return has been specified. Okay, again, you can make it into percentage or whatever you want. So suppose I'll make it for 5 days also, that is 1 week return. Okay, so the same thing I'll do with 5. So I want close returns on the 5th day. So basically today's close versus 5th day close. And I'll be changing the name of the variable D5 ret. Okay, now again I'll see. So I've got 2 returns, D1 ret, D5 ret. Okay, now why I'm doing this? Okay, so now I've specified the returns that I want. I want the gap, I want day 1 return, I want day 5 return. I've specified all of them in that row. Okay, next what I'll be doing is I'll be creating a condition. Based on that condition, I'll be filtering this data frame, and because of that, I'll be filtering rows basically. So we'll be specifying the condition which will specify that day's whatever variable we want. Okay, and that row will be selected, and I'll end up with a data frame of only those rows. Now, once I've ended up with a data frame of only those rows with the condition which specifies, okay, which I have specified, then I'll be easily able to calculate the summaries of the returns here. Okay, so let's do it. You'll get it by example. So suppose I want Fridays. Okay, I want suppose a green Friday. Okay, so that is the condition that I want, and I want the day 1 return after that. Okay, now for the for specifying Fridays, there is a specific function called weekdays. Okay, weekdays you run on the date to get the weekday. Okay, so I'll show you. NF dollar days is equal to weekdays on NF dollar time stamp. Okay, copy. Okay, now look at the NF. Now you can see that you have got the days, Monday, Tuesday, Wednesday, Thursday, Friday, and so on. Okay, now that I've gotten the days, I'm going to select out only Fridays. Okay, sorry. So Fri, suppose that is the new object that I'm creating. Fri is equal to NF such that NF dollar days double equal to Friday. Okay, so you can see that I've used the same method that I was using here. Okay, so within NF, I'm setting a condition that within that row, I only want those rows which have NF dollar days as Friday. Okay, so I'm making an object out of that. Copy, paste. Now let's see the head of Friday. You can see now that I've created an object which has only Fridays. Okay, now I'll be selecting out those Fridays in which the close was more than the open. Okay, basically meaning it was a green candle on a Friday. Okay, so let us see, I'll say a green Friday candle, GFC. Okay, is equal to Friday such that Friday dollar close is more than Friday dollar open as a row condition. You can see I'm using the same format as before. I'm specifying that I want the close more than the open, and only those rows need to be selected within Friday, FRI. Okay, that is the data frame. Copy, paste. Okay, now let's see GFC. So in the head GFC, you can see that only those days have been selected when the close was more than the open. So here it is just a 20 paisa close. Here it is whatever the difference is, 111.3, 112. So 10-point difference, approx 10.5-point difference, and so on and so forth. Okay. Now let me show you how the data has been reduced. Okay, we started at call data. Okay, so end row call data. You can see there were more than 2 lakh rows, 22 lakh rows, whatever, some 2 lakh or 22 lakh, whatever. Okay, next we reduce that to get only Nifty Bs. So how many rows is that? 1130. After that, we reduced it to get only Fridays. How many rows was that? 280. After that, only the GFCs, Green Friday candle, only 74 since the 2018 till 1st of July, 1st of August 2022. Okay, only that much. Okay, now that we have created that condition, we have filtered the data frame by that condition, and we have already created a return vector, that is the day 1 return, day 5 return. Then now we can just summarize that vector and get our returns. That is basically the back test. You are understanding what I do? Okay, so this point-to-point back test is pretty easy. This is how I do it. Okay, I know that I'm trying to explain it. It's seeming very lengthy, but when you get used to it, it's like and finish it off. Okay, so after this, GFC high range candle. Okay, so what I want is to specify the GFC, and so now I'll be using the summary. Okay, so I have already created a summary function. Okay, which will basically give me the returns like this. I'll just use that function, but you can eyeball that function, or if okay, let me just show you an easier way of doing it. Okay, so suppose I want to see the summary of the day 1 return. Okay, so for that the function will be summary of GFC dollar D1 red. Okay, same I'll do it for D5 red, and same thing I'll do it for gap. Okay, so I'm just running the summaries of these 3 vectors. I'll just clean the screen and see. Okay, so you can see that the median, okay, the median return on day 1 was 1 point, only 1 point. The mean return was 1.9. So already with this, you are able to know that it is slightly skewed distribution, in which positive returns are more common than negative returns. Okay, because the mean is more than the median here. Max is 43, min is -20. Again, skews in your favor. Okay, on day 5 return, okay, you have got a max Oh, Min, you have got very low. How come? I think this might be during the March 2020 crash. Probably. That one is being reflected here. And that is why the mean return on day 5 is showing very low. Okay. And then the gap return, again, I think this entire thing is being skewed because of that March 2020 crash. Okay. So there was probably one green Friday which had happened. And after that, everything had fallen down. Okay. Or probably one green Friday, Monday was green, and then after that it fell down basically. That is why in the day 1 return you are not getting anything, and in the day 5 return you are getting massive negative values, and on gap also you are getting a negative value. Okay, so maybe it gapped down on that day, closed slightly up, and then the next after that it just fell down. Okay, so see, that is how you need to think about this. Like you have to understand what the data is showing you. Like you remember that it is from 2018 to 2022. March 2020 crash would have been in this. And during that, there probably was one Green Friday candle because of this, because of which this entire result is being skewed. Okay. Now, suppose I want to create a histogram of this entire thing. Okay. So, histogram of suppose GFC day 5 return. Oh, GFC dollar. Sorry, I forgot the dollar. So here you can see that the day 5 return is showing. Okay. So mostly like 30 are between 0 and minus 200. More than 40 are between 0 and plus 200. And there was one in which there was a massive crash. Okay, because of this, the minimum value is coming like that. And because of that, only that day, the mean is being skewed towards the negative. Okay, you can see that the mean is minus 12, median is 2. So overall expectancy is positive, but it can lead to massive negative return. It led to massive negative returns once because of which the mean was skewed. And this inclusion of this data point would increase the standard deviation of your entire returns profile. And because of that, the risk will show to be high and all of that will happen. So you have to understand what is going on in the data before you try to interpret it. Okay. So let me just show you how the returns would be if I use my summary function. Next gap, next gap, next gap close. Okay. Okay, so this is just the returns of one day. Day 1 return it is trying to show. The next day gap returns basically I'm trying to summarize in this. So I'll just show it to you as a demonstration. This function can be modified in many number of ways. In this, I was just feeding it the entire data frame, and within which it was trying to look for the trying to do the calculations on the gap basically. So I'm going to modify it a little bit because my variable names are different. So next gap is basically gap in mine. Okay. ng perk it will calculate automatically. Yeah. Okay. So let me just show this to you. Then I'll be using it as summary func and GFC. Copy, paste. Okay. So now it has given me a data frame which I'll be pasting on Excel. Okay. So in this, you can see that everything has been automatically summarized. The total number of trades was 74. Let me just increase this. The total number of trades was 74. The wins were 54. Loss were 17. The Sharpe is quite low. 0.2. Risk is quite high. This is calculated on basis of SD of percentage changes. Average return is 0.3%. This is in percent. Okay. These are all in points, the Nifty points, Nifty B's points. Okay. These are all in percentages. Sharp is the division of this and this. These are just the number of instances. If you want to calculate the probability of wins, shift cells down. All you need to do is equal to divide the wins by the trades into 100. So 73% of the trades turn out to be positive for the next day gap. Okay, so this is a fairly good return profile. Okay, you can filter this, you can improve the conditions like I have done in my GFC RFC post. You must have seen on Twitter. So in that one, basically same on my website also. In that I had improved the filtration by specifying the trend conditions that I've discussed in my earlier post, the autocorrelation and the linear regression. So based on that, you can come up with multiple conditions to improve it in your favor. But in itself, a win probability of 73% is huge. Although occurrence of a green Friday candle is less. Understand? Because 74, only 74 out of how many? How many Fridays were there? Yellow Friday. So out of 218, only 74. So 74 divided by 218 into 100. So only 34% of the Fridays turned out to be green. So it's a low probability event with a high probability win rate. Okay, so you cannot create a full strat out of it, but it can be part of a strat, just like Quora does. Okay, so I hope this thing was useful for everybody, whoever watched it. If you want me to cut down on some details or increase some details, please let me know in the posts. I'll be publishing it soon. And thank you for watching. Bye.